Hello everyone, welcome back to my channel. So in today's video, we'll be discussing about the Prim's algorithm. Now, Prim's algorithm is a way by which we can find the minimum spanning tree for a given graph. So here you can see I have taken a graph and we'll try to find the minimum spanning tree for these graphs. So basically a graph can have many spanning trees, but here in this case, we'll be finding out a minimum spanning tree. Now what's a minimum spanning tree? That we'll be getting to know very soon. So the first step to find the minimum spanning tree is, you can see that in this graph we have some loops, right? We have a loop over here. So the first step is you need to remove all the loops that is present in the graph. No matter whatever the weight or the cost is there on the loops, first you have to remove these loops. So I will be removing this loop which is having value 1. That is the first case. The second thing that I'm going to do is, if you have any parallel lines in your graph, as you can see over here, you have 8 and 6. These two lines are parallel lines. So if you have any parallel lines in the graph, you are supposed to remove one of the parallel lines. Now how will you choose which parallel line you're supposed to remove? So on one of the line the weight is 8, on the other line the cost or the weight which you say is 6, right? So I have to remove the cost that is higher. So in 8 and 6, which is the number that is higher? 8 is the number that is higher. So I'm supposed to remove the edge that is having a higher cost. That is, I'll remove the edge with the value 8. So that is my first step. So I'm going to remove these parts. Done. So our first step is done. We have removed the loops and our parallel edges. Okay, so now we have got our graph over here, and now we will try to draw the minimum spanning tree for this graph. So the first step is you have to choose an arbitrary node. Now what does this mean? Choose any node from where you're going to start your tracing of the Prim's algorithm. You can choose C, you can choose D, E, F, anything you can choose. Now let me go by convention. Let me choose A as my arbitrary node. Now what am I supposed to do is, from A I have to see the nodes that are directly attached to A. Now which nodes are directly attached to A? We have B and we have C, right? These two nodes are directly attached to A. Now I'm going to attach A to that node which is having a minimum cost. Okay, so when the A is attached to B, you can see there is an edge that is having a cost of 7. And when A is attached to C, there is an edge that is having a cost of 8. So in Prim's algorithm, you're supposed to find the edges with minimum cost. So which is the minimum number over here out of 7 and 8? 7 is the minimum number, right? So here what I'm supposed to do is, I will attach A to B. Okay, and I'll write 7 because 7 was the minimum number, right? So we have got two nodes now, A and B. Now what you're supposed to do is, we are going to see the nodes that are directly attached to these two nodes. Okay, now the nodes that are directly attached to A is C. The nodes that are directly attached to B is again C and D, right? You can make out that thing with the graph itself. Now I'm going to see the edges which are having the minimum cost value over here, and they're directly attached to these two nodes, that is A and B. Okay, now which edge is having minimum cost? If you see, the edge that is going from A to C, it is having a cost of 8. The edge that is going from B to C, it is having a cost of 3. And the edge that is going from B to D, it is having a cost of 6. Now you know, out of 8, 3 and 6, which is the minimum number? 3 is the minimum number. So I'm going to attach B to C and I will write its cost, that is 3. So what we are trying to do here is understand the logic. Whatever nodes are present to us, like right now we have A, B and C nodes that are present to us. Now out of these A, B, C nodes, we have to see the nodes that are directly attached to these three nodes, and we have to compare the edges that is having the minimum cost. And the edge which is having the minimum cost, we will be putting that edge in our formation of minimum spanning tree. Right? Now out of this A, B and C, check out the edges that is having your minimum cost. Okay, so B is attached to C, and then you have C that is attached to E, then your C is attached to D as well, and A is attached to C. So out of these values, check out which is the smallest one. Now if you see here, C is attached to D, but the value of that is 4, and C is attached to E, the value of that is 3. Similarly, when A is attached to C, the value is 8, right? And then when B is attached to D, the value is 6. So out of these 8, 3, 4, 6 and all, which is the smallest number? 3 is the smallest number. So that is when C is attached to E. So I'll be attaching C to E and I will put its cost as 3, right? Now next step is we have 4 nodes over here, A, B, C and E, right, in our minimum spanning tree. Now out of these 4 nodes, check the nodes that are directly attached to them and find the minimum cost. Now you can see here E is attached to F with a cost 2. Again E is attached to D with a cost 2, and 2 is the minimum number. Then you have B also attached, you have C attached to D. So 2 here is the minimum number. Now you will be having a doubt. E is attached to F with value 2 and E is attached to D with value 2. So both of them are same. Now which node am I supposed to choose? Now this entirely depends upon you. You can choose any one of the nodes. The answer will not be wrong. You can choose any one whichever you want because both the values are same. You can choose E to D or you can choose E to F, right? So let me choose E to F and let me put it as 2. So you can choose any of the nodes. It doesn't make the whole sum as wrong because both the nodes are having the same cost, right? So that part is done. Now we have A, B, C, E and F in the formation. Now check all of these nodes and see which is having the minimum cost directly attached to its next adjacent node. So if you can see here, E was attached to D with value 2 and F is attached to D with value 5 and other attachments are also there. So which is the smallest number over here? 2 is the smallest number, right? And that is E when it is attached to D. So now I'm going to attach E to D and I'm going to enter the value as 2, right? So now if you check, we have visited all the nodes that was present in our graph. That is A, B, C, D, E, F. All the nodes have been visited that were present in our graph. So now with this we have got our minimum spanning tree. Okay, the minimum spanning tree which is present on the screen right now. This is how you trace your Prim's algorithm. Now there are certain properties which you can check to verify whether your minimum spanning tree is correct or not. Let me take my graph as, let me represent it as G V of E. So I hope you understand the graph notations. Here basically this G means for graph and V stands for vertices, E stands for edges, right? So this is how I'm representing my main graph. And suppose for my minimum spanning tree, I'll write it as G dash of V dash and E dash. That is, this V dash here is the vertices of minimum spanning tree and E dash here is the edges of the minimum spanning tree. Now the certain rules that I'm trying to tell about you is that first rule is V dash will be equal to V. That is, the number of edges of your graph will be equal to the number of edges present in your minimum spanning tree. Now here if you count the number of edges, we have 1, 2, 3, 4, 5 and 6. 6 edges are present. What about your minimum spanning tree? You have 1, 2, 3, 4, 5 and 6. That is, you can see that the edges of your main graph and your minimum spanning tree are same. So first rule has been verified. Second one is that your edges of your minimum spanning tree is always a subset of your main graph, right? And there is a formula also for that, that is the edges of the minimum spanning tree is equal to the number of vertices of the graph minus 1. So just now we calculated that the number of vertices in the graph is 6. So the edges of the minimum spanning tree will be 6 minus 1, that is nothing but 5. Now you can count the number of edges. This is the first edge, second edge, third, fourth and fifth. So you can see here that we have got 5 edges in our minimum spanning tree. So with this you can make out that your minimum spanning tree is correct. So these are two rules that if they ask you, you can say that these are the rules to find out your minimum spanning tree. So here we have got your minimum spanning tree. So basically a graph can have many spanning trees, but this is what we have found out is a minimum spanning tree. A minimum spanning tree basically means that it will have the minimum total edge weight. Now if someone asks you how to find the total edge weight, you're only supposed to add the cost which is present in your minimum spanning tree. That is, you have to add 7 plus 3 plus 3 plus 2 plus 2. So when you add all of these separate costs that you have got in your minimum spanning tree, you will be getting your total edge weight. And the total edge weight will be minimum out of all the spanning trees that you can form for this graph. And then only your spanning tree becomes a minimum spanning tree, because the total edge weight that you have got is minimum. So that's how you can find out and implement your Prim's algorithm. Now that's all for this video. If you have any doubts, you can put them in my comment section and I'll be reaching out to all of your doubts. So thank you for watching this video and meet you in my next video.